So in previous lecture we will see that so how the when our D is large, when actually our D is large, then KDT is failed to handle this kind of situations. When D is simple large, so in such cases our KDT is fail. But the locality sensitive hashing to overcome this kind of situations when D is a large set. So first, to understand the locality sensitive hashing, first understand what is actually hashing means. So let's take an example. I think the example will be clear for a better understand. Suppose let's take this is our an unsorted array. Suppose let's take this is an our unsorted array. So let's element is 2 1 5 6 7. Let's add two more, 5 8. Okay, let's take, and this index is, suppose it is index is 0 1 2 3 4 5 6. So this is the index of this array. Okay, this is a simple unsorted array. Okay, now what is actually has tables means. Actually hash tables means is nothing, it is a simple a data type of data structure. Hash table is simple look like this kind of structure. There have pair of values, there have one is key value, one is called the key, and one is called the value for this key. Okay, this is the simple structure of. Here we have 6 cells, so corresponding to excel we have 1 2 3 4 5 and 1. Let's this one. Okay, now the hash functions hash table is nothing. We have actually we have stored this value as a key value. Suppose let's take, we are taken here 2. So in the place of 2, in the place of, suppose let's take, in the place of 2 we have stored this 2 as a key, and corresponding value will be its index. So what is the index of 2? Here 0. Similarly for 1, suppose let's take, so let's take 1 will be stored, suppose let's take here. So anywhere, so how we will decide it where in the hash table this value will store. So this thing will be decided through a mathematical function that's called a hash function. This is simply a mathematical functions. If you are interested, just search on the Google how to build a hash functions, or simple find it on Wikipedia. I am not discussing how this hash function. So these functions is doing the job in where this value will be stored. So suppose let's take it 2 will be still the first positions, and corresponding value is the index. Suppose let's take 5. Suppose let's take our hash functions giving the value, transfer this value to the hash table. Suppose it looks like these positions. So what will be the index of this value? 2. Now if you just see here also, here happen another 5. So the hash functions, the same file, the hash function will do the job, the same 5 will be stored in the same key, as a same key, and we have simply increased the value of the value of hash table. So here what in previously we have stored 2, and in again we have stored here 5. This is the simple structure of the hash table. And one thing, the one thing is that the finding the element. Suppose let's take, if we find the 5 is exist or not. Suppose find if the element 5 is exist in this array or not. If 5 is exist or not, let's see. So if you just consider the linear search or brute force search, so we have to compare each element one by one. That's simple. In such scenario we have seen in that it is order is time complexity is order of n. If we just simple taking the linear search, linear search. If we take in the simple linear search, its time complexity is order, but if you take the simple hash table concepts, so its order of is equals to simple a order of is here, order time complexity is constant time complex, means order of 1. Its time complexity for hash funds for hash table, this time complexity is order of 1. So how this doing these jobs? Actually, we have seen that we are interested to find the value of 5. We have interest to find the value of 5. So here we have the hash functions corresponding. If we apply the hash functions, it gives the value 2 and 5. We are going to the simple 2 and 5 positions and pick up the value 5. Where? Okay, we have simplified that. In 2 and 5 we have find this value 5. Okay, we can easily find the indexes of this corresponding to find. This is the simple order of time on complexity. This is if you just simple how to build. If you Google it, you can easily find it. It is not a hard, and it is not a to build a mathematical hash function is not a hard task. You can easily build it. Okay, the value and so simple. I think this value is the simple indexes of a array. Okay, indexes of the array, this value is stored here, index. So this is the simple. And another language, some authors are this thing, some authors call the bucket. Okay, this thing is called the some bucket, some author. Now I think you have understand the hashing concept. Now let's come to the locality sensitive hashing. What is actually locality sensitive hashing? What is this locality sensitive hashing? So this is the central extensions of the hashing functions. Just see by using simple this hashing concept, how you will build a nearest neighbor algorithm. Suppose let's take we have data sets like, and another, suppose let's take another kind of data sets is like, okay. So the locality sensitive hashing to this job. Suppose let's take we have a query point. I'm using here white color for the query point. Suppose let's take it's the query color. Query point xq is here. Now we have decided the how much point we have interest to consider in our knn. Suppose let's take we are consider k is equals to 5 for our hyperparameter k. So we have find the k nearest neighbor for this point query point. Now first how to build the locality the same thing also doing here. We have built a table hash table like that. In one side we have stored the key, and another side we have stored the value. Okay, in the first column we have stored the key, so the key will be stored like that. Here will be key will be stored like that. Okay, suppose the nearest point, suppose we have built the nearest cluster point like that. Suppose this is one cluster using another. Suppose this is suppose if we consider k is equals to 5, so this is the one cluster for k is equals to 5. This points also one cluster, this one cluster, this one cluster, and this is one cluster, this is one cluster, such kind of like that. Okay, such kind of like clusters we are making by using simple, and we have chosen the hash functions. I have built the hash functions like a way, such a way that each clusters are converted a store here. All the points in this cluster are stored here, and its value will be what? Its value will be the point light on there. Means suppose let's take the value, the for this, for here we have taken 6 value, so the value of this cluster is look like that. Suppose if we have x1, x2, x3, x4, x5, 6 value we have in this cluster. So this, in this key, this value will be stored here: x1, x2, x3, x4, x5, x6. This kind of value we have stored here. Okay, this is the main thing. And similarly for this one, if this thing is transformed here, this thing will be stored here, and this value will be stored here. Here this value will be stored. Similarly for each clusters. Now we have given a xq. Suppose let's take query point, and we are finding the what is the its class level. What is this class level? So suppose if we have a query point, we have find which cluster it belongs to, means which nearest point we have belongs to here. Okay, simple, we are finding the hash of xq. It gives the value, it gives the key in which bucket we have to go. It's get the key. Suppose let's take, we have to go this bucket. We have to go this bucket according to this key value. We have to go this, and we are finding the value. It's near value. How easy this one? So according to that, we have decided what will be our majority vote in such cluster and what will be this. So this is the simple concept of the locality sensitive hashing. Just we have, according to our key value, we are building some small clusters value according to the key, and we are storing this thing in a hash table. Okay, and by using the simple hash value of our query point, we are going to this table and find our points of these local points, and according to that we have decided. This is the simple usage of the hash table. Okay, this is the nothing, this is the simple this is simple, the very useful, and we can see that after the next part of these lectures we will see that how using this kind of technique, locality sensitive hashing, we have built using a classification algorithms. Okay, and if we have d is very large, the main importance of this locality sensitive hashing is if d is very large, then we can easily handle by using this concept, locality sensitive hashing. I think the main motto, how this actually locality sensitive hashing is works, it will clear, and we will see this thing deeply in the next part of this series of lecture.